So here's what we're going to do. First of all, I like talking. So they shrunk me down from 1:15 to 45 minutes. That's not going to be easy. So I'm going to get started 5 minutes earlier with the hope that I can get through my slides. So I've got 55 slides to get through. There's a lot of content. The whole purpose of this deck, I sort of thought about how I should present this. And I vacillated between a few options. And then I basically settled on an approach where I said I'm going to put in enough content that post the conference, this content will be actually useful for you. So the content is mostly sort of giving you a high-level overview of the way you can build solutions, and it gives you pointers that you can actually use subsequent from the conference. So this content is going to be hopefully really useful to you after you are done with the session here. So what I'm going to talk about today very briefly is I'm going to walk through very briefly what the Edge portfolio looks like. Lots of people have gone through this. I'm not going to belabor too much time here. But then I'm going to really focus on what services are people using on top of Azure Stack and how are they using it and what should you consider when you're actually building solutions of that. I'm not going to go through all the services because there's quite a bit of them, but I'll talk about the key ones that people are using and those that are not being covered in other sessions. And then lastly, I'll talk about a couple of infrastructure investments that we are making, which will actually really help you think about how you should build about solutions in the context of Azure Stack Hub. So in terms of the Azure Stack portfolio, the family has grown dramatically. In March this year, we added HCI as a part of the portfolio, which really brings, if you're really interested in just virtualization, HCI is a great way to go. We've had a long-standing program in the HCI space, but qualifying it as HCI and giving it under the Azure Stack banner allows people to sort of really pick and choose the solution that it matters. And then yesterday, we added Azure Stack Edge to the portfolio, which is Databox Edge. So it's a growing portfolio which meets a spectrum of solutions. Now, I know there's going to be a lot of hand-wringing about, well, now there's so many things, I don't know what to use where. The data is there, the collateral is coming, so hopefully you'll be able to really identify what is the right thing to use at the right, at the right spot. But what I'm going to focus today is specifically on what are the services that are there on Azure Stack Hub. I'm not going to go too much out into the future. I'm going to try and tell you what is available today or what's shortly available, and how do people actually build solutions and what should you think about when you use these components. IaaS, that's a big part what I'm going to talk about. Data services, of which we announced yesterday as a part of Azure Arc. Container services, which there are other sessions which will talk about AKS engine and so on and so forth. App services that's available on Azure Stack Hub. IoT solutions and the infrastructure that goes along with it to enable you to build IoT solutions. And Event Hub, which allows you to stream ingest events, which is a very common pattern that we see with customers. So just to give you this context, the way I actually built this content is over the years that we have worked with customers with Azure Stack Hub, we've really understood what people use Azure Stack Hub for. So I've removed all the names from customers from here, but what I've really focused on understanding what do customers actually use Azure Stack Hub for, and that's what we're trying to share back with you as a community. So first, IaaS on Azure Stack Hub. I'm going to keep banging this point. IaaS is not virtualization. IaaS is a service. Infrastructure as a service is not virtualization. And what I mean by that is pure virtualization is you pick up the phone, call the operator and say, hey, I want you to create a virtual machine. And then that individual asks you all sorts of questions about filling in 10 template questions. Then you fill in a ticket, and at some point later you get a virtual machine. IaaS is self-service. It is something that you as a consumer actually use. But most vitally, it offers a set of automation capabilities inside the VM at launch time, which are incredibly powerful, right? Most people make mistakes. For example, when you talk to an IT administrator and they'll talk to you about, when you want to spin up a VM, you want the virtual machine to join a particular domain, you want a bunch of shares to be exposed to that entity, you wanted to install a couple of agents, you wanted to do a couple of things in the context of setting up application capabilities inside that virtual machine. Well, guess what? All of those things can be automated with infrastructure as service on Azure and Azure Stack by virtue of in-guest extensions, which allow you as an IT pro to automate all these common error-prone tasks by writing code which each time a VM of that type is launched will actually get that benefit. And so therefore, do not underestimate the value of infrastructure as a service. It's an incredibly powerful tool that you as IT pros now actually have to really focus on sort of the delivering value to your end customers, So lift yourself up from the mundane world of virtualization and bring your customers to infrastructure as a service. And it's a tremendous value proposition that you can bring to them in that context. So what we have done is, based on how Azure has evolved its IaaS platform, Azure has published a whole bunch of guidance on how do you deploy typical application patterns in Azure, right? And so what we've done is we've taken the most common ones of them based on how we see them being utilized and consumed, and we've talked to our Azure Stack customers, and based on that, we have said, here are the common ones that we have published. We've, I think, published 5 or 6. They went live yesterday morning at 10. That QR code will actually get you to them as well as the link. And so there's some common patterns about deploying a Linux VM, deploying a Windows VM, but more importantly, there are examples of how do you deploy an N-tier application on Azure Stack Hub, right? So this is a very typical pattern that you have. Your front-end portion, you've got a middle-tier application platform, and then you've got a back-end database infrastructure. So what this application pattern really tells you is how should you deploy that application pattern on Azure Stack. And what should you consider, which is you have to look at it differently from the context of Azure. Because Azure Stack is a subset of Azure Stack. I beg your pardon, Azure Stack Hub is a subset of Azure. So for example, we don't have application gateway that's available on Azure Stack Hub. So how then do you deploy an application gateway capability on Azure Stack? That document actually tells you that you have an option of deploying third-party application gateways from Kemp, F5, and so on and so forth, which will allow you to accomplish the same application pattern that you can accomplish in Azure, but it gives you guidance on how you can accomplish it in the context of Azure Stack. This is a very, very common pattern that we see customers using. The next one, which is actually really vital to think about, is when you're deploying an application, customers come and talk to us about, I want a available application that is not dependent upon the failure of one particular data center instance, right? How do I handle DR in that case? This is a very common pattern that allows you to sort of protect yourself from those kinds of failures. And the way you do this is you actually deploy 2 Azure Stack instances, or maybe even 3, across different data center instances. So they are going to be for individual Azure Stack instances, and from an infrastructure perspective, you have to manage 3 of them independently. But your application is deployed in such a way that the application itself is deployed in a resilient manner over that underlying 3 or 2 or 5 instances of Azure Stack Hub. So for example, you deploy the web frontend across these 2 or 3 instances, place a global traffic manager in front of them. Now, a global traffic manager is not something that is available in Azure Stack, but it's available in Azure. So you can either use global traffic manager from there, or you can use third-party load balancers. So spray your front-end load across these 3 instances of the web front-end, and then your back-end tier can be deployed as a SQL always-on availability group across the entire 2 or 3 instances of Azure Stack. And what this will give you is the ability to provide the customer a resilient topology of a deployed application. And what I want really all of you to think about it is not just about the raw guts and bits of the underlying infrastructure. You really have to have the conversation with your application architects about what are they trying to accomplish. And then using this kind of guidance, you can actually give them approaches on how they can actually make that available or provide that kind of resiliency to your customers. We'd really appreciate feedback on what additional sort of patterns you'd like to see us develop, and then we'll certainly continue to sort of populate and provide this guidance to you. So here are the first few ones that we've published. They're available and are online for you, available to go today. Next, in the context of IaaS, I think Natalia talked about it as well. So we are announcing the preview of N Series VMs. Last time at this conference, I actually talked about this and being in development. So we are now in a good shape. We're actually going to put this out in preview in the first half of calendar year 20. And if you're interested or your customers are interested, please use that link and sign up for that preview. And then we'll be able to sort of include some of you in the context of the preview. So how does an N Series VM support really work? First of all, N Series in Azure is about all VMs which actually have a GPU projected into the virtual machine. From a technology perspective, there are a couple of ways to actually project a GPU into a virtual machine. The most high-performant way, and the one in which you literally provide a physical GPU directly into the VM, is called as direct device attachment. Right? And what effectively you do is on the physical server, you have like 2 or 4 GPUs. And when you spin up a virtual machine, you directly assign that GPU into that virtual machine. That means no other virtual machine is using the GPU. That VM uses that GPU in a completely dedicated manner. Normally, this kind of operation is used if you're trying to do compute. You want to basically run highly parallelized, compute applications, which can actually use the GPU using something like CUDA or something of that sort. That's a great application use of that particular GPU. And those are you use them normally for intelligence, artificial intelligence, inferencing, and so on and so forth. So for that, we've got at least two of them. We have the NVIDIA V100 series as a GPU, which will be available in direct pass-through mode for NC series of VMs in Azure Stack. And then there are cases where you actually want to do, like remote desktop. You want to provide high-performance visualization kind of applications. You want to run AutoCAD and so on and so forth in a VM. And so there, essentially, what you do is you take a GPU, and by virtue of a technology called single root I/O virtualization, SRIOV, you can partition the GPU and then project a virtual instance of that GPU into the virtual machine. So even though you may have only like 2 GPUs, physical GPUs in the server, you can partition it into 4 each, and so you get the ability to run 8 VMs with that, or 8 or so on, and so, depending on how many partitions a particular GPU supports. But let's assume it supports 4. So with 2 GPUs, you'll be able to spin up 8 VMs, and they can actually multiplex the use of the physical GPU. 4 VMs will be able to multiplex the use of that GPU. And so those are called NV series, and we are starting with AMD there, but eventually we'll be able to get NVIDIA series there as well. And lastly, we're going to have an NVIDIA T4 available for work as well. We haven't decided what exactly it will look like. Topologically, it will just look like another Azure Stack instance. You'll have a hyper-converged compute and storage stack, but along with that, the servers will have from anywhere between 1 to 4 GPUs, depending upon the hardware vendor that you're talking about, right? It has to be homogeneous, so you can't actually have an Azure Stack scale unit where some servers have GPUs and some don't. All of them will either have GPUs, or all of them will either not have GPUs. Now, you will be able to run non-GPU VMs on these servers as well. But when you spin up a GPU VM, we'll basically deploy it onto these hosts, and using one of the 2 approaches, we'll actually attach the GPU into that. All right? Next, I want to talk about Azure Arc data services for Azure Stack Hub. This has been a huge deficiency for Azure Stack for a while. We didn't have a robust data services story for Azure Stack. And the SQL team have been working on it for a while. We obviously had the ability to run SQL inside a virtual machine. We also had a very rudimentary SQL and MySQL provider. But now we truly have a robust hybrid ability to bring data services on top of Azure Stack and any third-party infrastructure for that means. And so Azure Arc data services are really about providing a control plane in Azure and then providing you with a package which needs to be fed to a deployed Kubernetes cluster. How the Kubernetes cluster came about is not the responsibility of Azure Arc data services. You need to have a deployed Kubernetes cluster. Once you get that, you point the Azure Arc deployment package, so to speak, to that Kubernetes endpoint, and the Azure Arc data services will spray themselves onto the deployed pods of the Kubernetes cluster. Now, once you do that, you have a couple of options. You can take that Kubernetes cluster independent of Arc. Independent of the data services. You can point it to Azure Arc, and you can manage the Kubernetes cluster directly from there, from Azure as well. But the Azure data services themselves, they actually also have a management plane in Azure. And so the Kubernetes cluster can be managed by Azure, and your data services deployment itself can be managed from Azure as well, right? So why would you actually deploy Azure Data Services and Azure Stack Hub as opposed to any other infrastructure? Well, a couple of reasons. First, we've got a very robust story for how you actually deploy a Kubernetes cluster on top of Azure Stack. We've got AKS Engine, and the AKS managed service is also eventually coming on top of Azure Stack Hub. So you don't have to worry about how Kubernetes lands on top of Azure Stack. Plus, you get the fully integrated support experience that you can offer to your customers, because when we deploy Azure Arc data services and Azure Stack Hub, we make sure we do all the validation end-to-end for that capability on Azure Stack, the Kubernetes cluster that's deployed. And then lastly, by virtue of all the integrated work that we do with our hardware partners, you get much more predictable performance in terms of the storage, compute, and networking that you can get on Azure Stack data services and Azure Stack Hub. All right, so what I'm going to do now is I'm going to very briefly give you a demo on Azure Arc Data Service and Azure Stack Hub. And what this demo really about is, this is actually a map of the Orlando area. And what it's actually doing is that, this is assuming that, there is a city which actually wants to provide, emergency services to the city. And by virtue of the fact that it's a solution which needs to provide emergency services, think about hurricanes and so on and so forth, this is actually not running in Azure. I mean, a solution like this can obviously run in Azure, but imagine if you have to set up an emergency response center when something is going wrong, or you can't have network connectivity, how would you actually provide that capability? So this is an open source mapping software which is actually deployed in Azure Stack. And if you actually see here, you can see all the resources that are actually hosted on Azure Stack Hub itself. All right? And so what we've done is, this application basically, and so now we've overlain all the sort of emergency response capabilities that are going to be used by the emergency staff in this environment, right? So you got police stations, you got hospitals, you got supply depots, and so on and so forth, right? And so, for example, here, if you look, what's happening here is that, I can tell you that this particular medical clinic, what's the status of the injured that are coming into this particular hospital, right? So the emergency response command center actually has all this visibility in this at their fingertips, right? This is another example of a supply depot, and it gives you all the information there. Just to break a little bit, a long time back, I was in the armed forces, and so I actually did have had the opportunity to use this command and control software when you're actually in an emergency situation. And in those days, literally, we had radio operators who would radio us this information, and we would actually manually enter it in and then put it on a physical map. This kind of value is incredibly useful when you're actually trying to plot and understand how you're going to deploy resources when and where to actually accomplish what you're trying to accomplish for rescuing people. Right? It actually literally means saving lives at some point of time. So this is the information about the depot. And then now let's basically take a look at how this application was really constructed. So that's really powerful for the end user. But this application is really constructed of a couple of different things. First, it is using app services that's running on top of Azure Stack. And this is actually the app services front-end deployment that's actually deployed on the Azure Stack instance itself, right? And then next, it is actually using a Azure Arc data services cluster. So all the data which says, the hospital has so many, patients, that's the supply depot status. That's all actually that's been that's available here. And in reality, just consider how is the data that's coming in to actually feed that input. Where are you getting the data from in terms of the number of patients in a particular hospital? So that kind of an application is normally constructed with an event stream. And an event stream is best serviced using an event hub. So an event hub is basically an ingester of any kind of event stream. So although I'm not showing event hubs here, but this application actually uses event hubs as well to actually get in the data from all the sources of input, whether they are sensors, human input, any kinds of information, collates it, pushes it into the Azure Arc data services, which can then project it to the Azure App Services front end, so it's available for the application all up. And this next view basically shows you the deployed instance of the Azure Arc data services, but being managed from Azure should you want to do that, right? Now, obviously, I told you the solution is to work in disconnected scenarios, but if you do have the Azure Arc data services connected up to Azure, this is how you'll be able to see that deployed managed instance, and you can actually see all the data instances and pods that are deployed in the Kubernetes cluster. Okay. Now, this basically gives you a very high-level view of how these things were actually deployed. So on the Azure Stack Hub, you had various feeds coming in from various parts of the data source on the data services, and then we had Azure App Services actually providing their functionality to the customer. All right. So the next thing I want to talk about is event hubs on Azure Stack. There are many, many use cases of event hubs. I just showed you one in the context of a data stream. But think about any place where you're gathering large amounts of data which is coming in asynchronously. That's where you actually want to use event hubs. So event hubs is basically the front door for any eventing pipeline, right? So if you have a large number of sensors on a vehicle, you have IoT sensors deployed in the factory floor. You have, in a manufacturing plant, you actually have a lot of these sensors which are gathering data from various robotics elements that are actually controlling the factory and manufacturing. All that data can be streamed in through an event hub that's actually deployed on top of Azure Stack. You can then use something like Azure App Functions or Azure Functions to actually do processing of that event stream, right? So you may want to sort of filter out all a particular event stream which doesn't meet your criteria for that particular time series, remove them out, and then you can either store them, and then if you want to do further processing and you are in a connected environment, you can then pump it up into Azure, which can also have an event hub ingester there, which can then do further detailed processing of events in Azure as well, okay? All right. So the next thing I wanted to talk about is the investments that we are making in three major parts of Azure Stack: capacity, availability, and management. Now, these are very important facets that you all need to consider when you are actually deploying solutions on an Azure Stack system. You all are solution architects and people who advise how people should actually build solutions on top of Azure Stack. So the first thing is investments in capacity. And we are looking at these investments along two vectors. Along what happens when you start to run out of storage. By the way, one thing, and I should have said this earlier, I assume that you already know what Azure Stack is, so I'm not going to spend a lot of time on what Azure Stack Hub is. But very briefly, is there anyone here who doesn't know what Azure Stack Hub is? It's too late now, nobody will even admit it. I'm really sorry. Okay, so the Azure Stack Hub architecturally is basically a hyper-converged architecture, right? And hyper-converged architecture basically means you take a physical server, you jam a lot of storage into it. And generally, you will actually have tiered storage. You'll have SSD and disks in it, and you have a bunch of these servers. You hook them up through a switching infrastructure, and then you layer on top a software piece, which then consolidates all this storage and pools it up, so you can use it like you would use a typical SAN, right? That's the whole notion of software-defined storage. So it's hyper-converged in the sense that you actually don't have a separate set of machines which provide you storage. Your compute and storage come from the same physical server. So hyper-convergence is a pretty big deal today because it allows you to come up with high-performing, good quality, available storage at a much lower price point that you never been able to do this in the past, okay? And so one of the interesting fallouts of using a hyper-converged architecture is that you actually, if you have asynchronous growth of storage. So for example, a typical example is, let's say you're running Exchange. Not a very recommended thing to do on Azure Stack, but still, let's assume that you're running Exchange. And if you're running Exchange, you're going to end up with very large amounts of data, but your compute requirements are relatively small in the context of Exchange. And so that's an example where your compute requirements won't grow, but your storage requirements will grow dramatically. Or think about a solution where you're trying to do IoT event processing, right? IoT sensors generate tons and tons of data, right? I was involved recently in an interesting defense contract somewhere in the world where they were required to ingest like a petabyte of data in like 2 days or a week, right? So just imagine if you're trying to ingest a petabyte of data, where are you going to store that data? Because a hyper-converged architecture in Azure Stack limits how much of storage you can get in Azure Stack. Even if you go to the maximum size of Azure Stack, which is 16 servers, you can roughly hit, depending upon the max size of the SSD and the disks, you'll pump it up to about maybe half a petabyte of storage on Azure Stack Hub, right? Now that is not going to be adequate if you're going to ingest that kind of data. So how do we solve that problem? So the way we've solved that problem today is that you can actually connect external storage out from your border devices. And so you can connect a NetApp filer, you can connect an Isilon, you can connect a Nimble storage, you can connect it externally, and you can access that from your workloads like virtual machines running inside Azure Stack through a file protocol like NFS or SMB, or a block protocol. The only block protocol we support is iSCSI, right? Now this is what we do today. In the future, what we're going to do is, if you actually see this slide where today Okay, today you see this device, the external filer is connected to the border device. We've actually done some work where we can reduce this hop and actually connect this device directly to the leaf switches which are in Azure Stack, right? So there are two benefits you get out of that. One is, you get reduced hop, but the performance is actually not gated by that hop because the network traffic is bound by the software-defined infrastructure that we have in Azure Stack. So that's probably going to be more a gating factor. So it's not the hop that I'm more worried about, but by doing that, our hardware partners and solution partners can actually build integrated solutions. So they can sell you a solution which has been thoroughly validated with the storage, well integrated into the leaf switch or top-of-rack switch, depending upon which generation of networking you grew up with. So that allows you to actually have an integrated storage solution along with the Azure Stack capability. Now that we actually have Windows Server 2019, I will also point out that we'll get much better throughput because of the SDN infrastructure in Windows Server 2019 is much more higher performant. Now, it won't happen just automatically just because you got 1908, which includes Windows Server 2019. There is work still left for us to do. But once we actually get the high-performance gateway SKUs, you'll be able to get much more throughput out from those gateways compared to the 200 megabit limit that you have today. You'll be able to go up to north of a gig and a half on those gateways once we actually do the work. And we anticipate doing that fairly short order. But again, I don't want to make any commitments on timelines just now. Yes. Yeah. So that's a really good question. The question really is that can I basically place the OS disk for those virtual machines on that external filer? The short answer to that is no, not at this point, but we are working on some capability which will extend our blob capabilities on top of this external functions. But that will take a little while for us to actually completely get through. There is a bunch of work left for us to do. But as a start, virtual machines inside can actually place this data. And if you actually go look at what's happening in the data centers today, this is a very common pattern where either VMs or physical machines are actually accessing external storage through some kind of a block protocol, either iSCSI or, block or file. And so this is the same pattern that you can accomplish in Azure Stack today, but you can't actually place the boot disk on the external file just yet. Save the files. And it's a good example for like an IoT solution where the IoT input can actually be stored externally. All right, so the next one, this is a slide or part of a slide I actually used last year at Ignite as well. This talks about how are we thinking about adding scale units. So the first thing to understand is that we have, like I said, this development of scale unit is available and it should be available by the end of next calendar year. By end of calendar year 20, we should actually have the ability to have 2 scale units in capacity mode. And it's important to understand what I mean by that. So this is what today a single scale unit looks like. So it connects, your Azure Stack instance comes with leaf switches which connect up into a border device. Those blue boxes above the yellow boxes indicate the Azure Stack software. The XRP ring, the CRP, the NRP, the update RP, all of the stuff that is Azure Stack itself. And the green boxes are customer workloads. So here is what we'll do. When we actually get a second scale unit, you'll actually get a second layer of switches on top. You'll get some spine switches, right? And the leaf switches that will route through the spine switches back up into the border devices. Now, it's important to note that when I added this, I put all the workloads down. And what I mean by that is adding a second scale unit is not going to be, I want my workloads to keep running. It's not going to run. You're going to have to take downtime when you add the second scale unit, right? Now, if you look at it, there are a couple of subtleties in the way the second scale unit came up. We do not anticipate the requirements of a hardware lifecycle host with the second scale unit, right? And so this is how it looks. But most importantly, look at how the actual deployment of the application looks. So the green workloads are the customer workloads. They will naturally deploy across the across a second scale unit. And your experiences, your ARM and Portal will use all of the capacity to deploy resources. But most vitally, the Azure Stack software is still sitting only on scale unit 1. And that's what I mean that this is only a capacity statement. So that means scale unit 1 is special. I can't make any guarantees that if scale unit 1 goes down, that the whole system will not go down. right? So we'll start with the capacity expansion model, and then eventually we'll get to a place where we'll make our software more resilient and deploy that Azure Stack software across multiple racks as well. But to start with, we'll start with just a capacity expansion. Yes? I said yes, but not initially. The question was, do you plan to expand the management part over time? I said yes, but not initially. That's why the initial statement is only a capacity statement. It's not an availability statement, right? Because there are customers who are starting to run into the limits of what a single scale unit capacity can suffice, right? Now, I completely understand that customers would like the ability to make a statement which says that, look, if one rack goes down the entire system, we won't start there, just to be clear. We'll start by capacity and then add. And to be honest, to get to a resilient statement, I'll need to get to an odd number of scale units. So I'll probably have to get to the third scale unit. And when I do that, then I'll actually spread the Azure Stack infrastructure across those three, and then I'll be able to make it happen. So back in 1905, we actually announced the fact that we are containerizing all of Azure Stack itself. And there was a bunch of press about it, that they discovered something magical. There was no discovery. We had it out in a release note, so I don't know what discovery people are talking about. So just to let you know, yes, we are absolutely proudly doing anything to make our Azure Stack infrastructure better. So we are actually we have put the basic building blocks in place to actually containerize all of Azure Stack itself. I'm not talking about when you want to run containers. That's a different story. You can do that today. But we want to use containers inside Azure Stack itself because it makes our infrastructure more efficient. It allows us to patch more efficiently, and there's a bunch of benefits that we get by containerizing our own infrastructure. So starting in 1905, we put out the first set of release notes which said, yes, we are putting out these VMs because that's where we're going to host a bunch of containers. And the next set of enhancements, in fact, in 1910 release notes, you'll actually see that we want you to start giving us a /20 private address space. Right? And we'll block you in 1911 if you don't give us the /20 private address space. Now, it's important to understand it's a private address space. So it's a private space which is purely internal to Azure Stack. But there are some nuances how we actually use that address space. You can't have an address from that address space conflict with another private address in somewhere else inside your data center. Right? So we'll give more details when we actually release 1910 release notes. But these are things that we are doing where we want to seal off Azure Stack internally from a network standpoint more and more. So then we can actually do all these things under the covers inside Azure Stack and make it much more efficient. All right? So investments in availability. So yes. Yeah. Great question. Physically, it will just look like any other piece of metal. Okay, I'm not joking. I'm so joking. It's going to look like, no, it's not an availability zone. That's why I want to keep insisting that it's not an availability statement to begin with, right? What will happen is that our deployment engine, when you actually go deploy, and placement engine, when you actually go place workloads on Azure Stack, it will just see an expanded pool, right? With one subtle difference. We actually have a way to tag the scale unit with saying, this scale unit has these capabilities. So a typical example would be that the second scale unit could contain all GPUs. In which case, when you go to place an N Series VM, the deployment engine knows that the second scale unit has GPUs in it, so it will then route the placement and creation of that virtual machine onto the second scale unit, right? So from a customer standpoint, you actually won't see the fact that there are two scale units. You will just see more capacity that's available for you as an infrastructure operator. Does that make sense? And over time, when we actually add availability zones and availability sets and spread our infrastructure, then we'll be able to make a more availability statement as well. But to start with, it's a capacity statement. Does that address your question? Sure. So important to understand that Azure Stack has single system guarantees. And what I mean by that is that when you deploy an Azure Stack instance, it has a bunch of resiliency built in right from the hardware up into the software. So for example, if you look at the bottom of the slide, it talks about hardware fault tolerance, right? So we have redundant pairs of switches for top of rack, right? So if you have one switch failure, we'll be able to sustain that failure, by and large, we've designed a system for N-1 failure. That means I can take a failure of one element something or the other. I can take a failure of one server, I can take a failure of one switch, and so on and so forth. So that's the hardware fault tolerance. And then I have platform resiliency. By the way, on the hardware fault tolerance, there is a long, detailed slide that we presented last year, which talked about disk tolerances and storage tolerances. How many disk failures we can tolerate at a particular time, and so on and so forth, right? And so we can sustain a bunch of those failures, but like anything else, right? I mean, if you start failing beyond a certain amount of physical failures, then your system will start failing beyond a certain thing, right? So then you think about how do we build platform data and resiliency. In Azure Stack, all data is got 3 copies, right? And 3 copies are stored on 3 physical server instances. So you can lose, that's why we can actually lose a server and it's fine. But there are instances where somehow, sometimes, and some of you who use Azure Stack, find yourself in a situation where you use 2 data instances, and that's when we really become extremely cautious, and we'll start shutting down the system because we don't want you to lose data at that point of time, because a single copy of data is a very risky state to be in, okay? And then if you go further up, we've got availability in terms of if you're running a singleton IaaS VM on any one of the servers in Azure Stack, and that server fails, that VM will automatically be brought up on a different instance of an Azure Stack node, right? Now, obviously, because it's like yanking your power from your desktop. Your desktop means everything will go, but it'll come back when in a few minutes, depending on how long it takes for the OS to boot up. It'll come up fairly quickly on the second side. So it'll be in a crash consistent state at that point of time. But if you're really looking to actually build high availability applications, then the IaaS guidance that I talked about previously, build your application so it's deployed across multiple Azure Stack instances. That's the way, really the way to go. Make sense? All right. So this is an example of how you can actually protect our workloads if you have the regulatory ability and the connectivity up into Azure. So you can actually fail over into Azure using Azure Site Recovery, right? So Azure Site Recovery is an Azure DR function capability. You deploy an agent inside the virtual machine, and it can replicate data up into Azure, and then you can fail into Azure, and you can run that virtual machine in Azure, right? Now, I would have liked to actually have a much better automated way to actually fail back. So there is a bunch of work that you have to do to script to actually bring the fail back, but it's still doable today. So in case this is an option for you, I strongly encourage you to use Azure Site Recovery to protect your VM, so you actually have DR capability available as well. Second, we've got Azure Backup. If you have the ability, again, to back up data up into Azure, you can use the Azure Backup Server. You can actually back up data up into Azure. You want to do 99-year plus retention in Azure, that's perfectly fine by us, okay? But there are customers who actually cannot, for a variety of reasons, connect up into Azure and use DR and backup from Azure, right? So I'm going to talk to you about some examples, prototypical examples of how we do hub-to-hub DR with variety of partners who've actually built solutions on top of Azure Stack, right? So what effectively you do is you basically connect up 2 Azure Stack instances which are deployed to 2 different data centers, and any DR solution like this has a couple of building blocks. You have something that replicates the data from the primary site to the secondary site. You have something which is a management plane which actually orchestrates, the mapping of how this VM needs to be when it shows up on the secondary site. And this orchestration engine is used to actually perform the DR plan. What happens? Shut it down, bring that up in this sequence, run this script, and all that, so on and so forth, right? And so we've actually published, some examples of this, and there are some great examples of partners who've actually built solution. Carbonite, Veeam, Veritas Resiliency Platform, and Carbonite. And what I'm going to do now is going to give you a very brief demo of the Veritas Resiliency Platform, which actually allows you to do DR orchestration for Azure Stack Hub between 2 Azure Stack instances with no connectivity required to Azure, right? And most importantly, because it has the sophistication of the orchestration engine built in, it gives you all the functionality to orchestrate DR. Because in any DR situation, right, you have to do a few steps. You have to actually bring up the application in a certain sequence. You want to bring up AD first, you want to bring up storage first, then you want to bring up the SQL database, then you want to bring up the backend, and then the front-end applications, just as an example, right? And there may be scripts you have to run. You may have to fix up IP address addresses, you may have to run a bunch of scripts to make sure that everything is running all the way through. And these orchestration engines, like the one that VRP has, allows you to do that kind of orchestration in the context of Azure Stack Hub, all right? So this is going to be in preview in 2020, and Veritas is here, so they're in booth 647. Do go by and talk to them. I'm going to briefly walk you through what a demo looks like. So here is an example of 2 Azure Stack Hub instances which have been paired using VRP. And so you have 2 instances, one on the West Coast and one on the East Coast, right? And then here is an example of an application, this one, which is actually running on the West US data center, but which has been paired into the East Coast data center, and its synchronization has been complete. So when you actually click migrate, what will happen is there will be a series of steps that will take place, which include, like, it'll stop the virtual machine, it'll unregister a virtual machine, and it'll do a series of steps. And these steps are customizable. So you, as the IT operator, depending upon your application requirements, can actually do what's right for your customer to actually provide this functionality. And then what happens at the end of this is you can actually see that this application is running in a different data center than what was running primarily. And it also does things like, initially if you're replicating between the primary site and the secondary site, so your direction of data is this way. When it fails over to the other site, you can pair it with another site and say, now I want you to be resilient with a third site so I can start replicating data off to a third site. So your application is still available. So a bunch of really good stuff that the folks in Veritas have done, so really appreciate their partnership. Go down and chat with them at this point of time. Dell EMC is also doing a bunch of work in terms of image level VM and blob protection. They are here as well, so please go down and talk to them. And they are also going into a preview in Q1 of 2020. Please go up and chat with them if you actually want to do or talk about solutions for backup and DR with them as well. All right, so patch and update. So there are a bunch of activities that an Azure Stack operator does. And one of the most important thing is updates, because we roughly ship about 12 updates a year, which if you count actually means 1 update a month, okay? So, all right, so first thing we did was we actually split up our updates into 2 different types of updates. We now ship what is called as an express update. We ship it about 8 times a year. And an express update does not update the operating system of Azure Stack. Right? So it stays away from the operating system, so there's no live migration of workloads. And this we do about 8 times a year. And then we ship a full update about 4 times a year. Right? Now, I say about 4 times a year because this can really depend upon if suddenly there is a cloud critical vulnerability that I need to ship an OS update for, then I'll per force ship it. Right? Like for example, the last full OS we shipped was 1908, which is Windows Server 2019. We don't plan to ship any one now till January 2020. Right? So and previous to that, we shipped 1905, I think. 1905 was a full update. So 5 was a full update, 8 is a full update, and then January 2020 will be a full update. Now, why is this important? Because the express update takes only 12 to 15 hours to deploy, right? And with 1910 or 1911, we'll make a confidence statement that your existing workloads that are running when you apply an express update will not take any downtime. Right? So that will happen for all the 8 updates that we ship a year. And then by the middle of next calendar year, we'll make a confidence statement that even with full updates, you will not take any downtime when you're doing the full update. Right? There are some subtleties because of the way the full update works, because of live migration and storage resync, which prevents us from making the statement now. But even now, most customers, 90+ customers, % customers don't actually see any downtime even with full updates. But I can't make a confidence statement just yet. The other thing is we're also working in reducing the time of a full update, because today a full update can take north of 50 to 60 hours, right? Because we have to be really cautious in how we move data. There's a bunch of work that we are doing in the operating system which will allow us to bring that down to about 15 hours. That's our goal. We hope to be able to get there by the middle of next calendar year as well. So that will reduce the duration of full update as well as make a strong guarantee about the fact that it won't take any downtime. We provided an integration ability for all the OEMs to integrate with Azure Stack Update. So the same orchestration engine which we use to vacate nodes is being used by most hardware partners to actually orchestrate their patch and update. And that's an incredibly powerful functionality, because as we invest in improving the patch and update engine, the orchestration engine, all the hardware partners benefit from that as well. Okay? All right, so what happens if you've got multiple Azure Stack instances? I gave you this big story about, well, if you need resiliency in the application, you need to have multiple Azure Stack instances. But I know a bunch of you will say, oh my God, now you give me 15 of them to manage. How the hell am I going to manage it? Don't worry, we actually do have two things. First, we actually have a very good management pack that's available with System Center Operations Manager. This management pack is available now. We also have some open source code, so you can integrate it with Nagios and etc. and write your own plugin if you want to. But essentially the idea is if you have multiple Azure Stack Hub instances, you plug them into a single instance of SCOM with an MP, you can manage up to about 15 instances right now. It's not an architectural limitation, it's only what we have validated up to, right? And then because System Center Operations Manager has lots of integrations with ServiceNow and any third-party ticket management system, like that you want to use, like BMC Patrol and others, you can actually do that as well. And so it works agentless. You don't have to deploy any agents on Azure Stack. It just uses the native Azure Stack Hub APIs, and you can deploy across multiple instances. And here are some of the capabilities that you get as a part of that. From a single SCOM instance, you can look at the health of all your Azure Stack Hub instances. You can patch and update them. You can look at the status of each of the patch and update. You can initiate an update from them. You can look at what the status of the infrastructure backup is. You can do capacity management. And so you can do a whole bunch of things from the single pane of glass to be able to manage these multiple Azure Stack instances. All right? Extremely powerful functionality that's available now. And then earlier in Natalia's and Dean and Bernardo's session, you also saw a future capability that we are building, which is called Azure Stack Fleet Management. But that is, and that obviously requires for you to be connected into Azure today. Over time, we'll probably bring it down to Azure Stack Hub as well. But the benefit of that is that, and if you got a set of devices that you're managing, not just Azure Stack Hub, if you're managing Azure Stack Edge, it will give you a consolidated view to manage those devices as well. So again, we are investing to make sure that we sort of, get better and better in whatever solutions we have. But I do want to let you know that we've done a lot of work to make sure that the System Center Operations Manager management pack is available now and functions. And there are many, many customers who are actually using this today to effectively manage large number of Azure Stack instances. There are customers who've got beyond what a single SCOM instance can manage as well. There are customers who've got that many stack instances. So they have actually got 2 SCOM instances managing it, or actually maybe even more. But anyway, so in summary, Azure Stack Hub can be used to provide a robust set of solutions for your customers, right? And my hope is that I've been able to provide you a bird's eye view of all the things that you need to think about when you're building the solutions and all the capabilities that you have today in Azure Stack that you can actually use to actually build the solution. And I've tried to give you a little bit of sneak preview into what's coming in the future in terms of GPUs, in terms of scale unit, and so on and so forth. And we're going to continue to invest in making sure that we have a robust platform for you to work in. And we're going to continue to provide, we need your feedback to give us information about what additional capabilities do you need in Azure Stack in terms of guidance, documentation, and how can we help you better. All right, so that brings me to the end of my talk. I'd be happy to sort of take some questions at this point of time. There are a bunch of other Azure Stack Hub sessions. Please go and attend them. There's a session by Daniel and Tibi. Daniel will talk about details on the infrastructure. Tibi is going to talk a lot more about Azure Migrate and a bunch of other applications that you can build on top of Azure Stack as well. All right, any questions? Yes? Yeah. Yeah, so the question is, I'm actually connecting, an iSCSI to an iSCSI target externally, right? And I want to be able to connect to the iSCSI target. Remember, an iSCSI target is an outbound connection from the VM that's running inside Azure Stack. So you don't have to use a public IP. Now, the reason you might want to use a public IP is for throughput right now. Because if you don't use a public IP and if you use a private IP, then you'll be going through the SDN stack and then you'll be going through the muxes, and that actually constrains how much you can actually get. So going out through using a public IP is probably better. But like I said, that's a constraint right now because of, we haven't done the work yet to actually improve the gateway throughput. Once we get past that, hopefully at some point of time, then you should be able to use private IPs as well. Make sense? Any other questions? Yes? So the question is, how is it with data services? Do you install the database or not? Is that the question? Great question. So are you specifically asking about the data services that I just talked about? Okay. So for data services, you have to first deploy the Kubernetes cluster, right? And for deploying the Kubernetes cluster, we have an ARM template for that. So you can just download the ARM template from the Azure Marketplace, and using that, it'll automate the deployment and creation of a Kubernetes cluster on Azure Stack completely. So now you have an effective running Kubernetes cluster. Now that you have an effective running Kubernetes cluster, now you take the deployment package of Azure Arc data services and point it to this Kubernetes deployed cluster. And then it will do its automation and deploy those data services on top of the Kubernetes cluster. So that's what gives you, and today they have two data platforms. They've got Postgres and SQL. So at the deployment time, I'm guessing you can make a selection, and then it'll give you those data services to be deployed on that particular platform. And then you can either manage Kubernetes using kubectl, if you're a command line person, or you can use a bunch of Kubernetes tools that are available, or you can plumb it up into Azure to manage it from the Azure Arc management. And then Azure Data Services, you can plumb into the Data Services management layer to manage it there. Does that answer your question? Okay. Any other questions? Yes. Oh, sorry. Yeah.
You have planned to direct routing from Azure Stack to on-premise, not using VPN.
Not using what? Sorry?
Not using VPN.
So the question is, do you have a way to, or do you have a plan to actually directly route from Azure Stack directly out to the Azure data center infrastructure? Not yet. You're still going to require a VPN, and we are working on giving you better throughput VPN solutions as well. But if you want, you can actually, and maybe this is a solution pattern that we can come up with. If you want, you can actually deploy RAS gateways inside the VM, and then you can use GRE tunneling up into the RAS gateways themselves. But that's something that you have to do, and I think there is work that we can do to actually provide that functionality. Be happy to chat with you more on that. Okay? Any other questions? Yes. Yep. Right. Right. So the question is, how are we enhancing our Kubernetes story? So the first thing is we've got AKS engine, which is GAing at Ignite, right? AKS engine means you run your configuration through an engine which gives you an ARM template, and you deploy that ARM template on Azure Stack. But then you're responsible for managing that Kubernetes cluster yourself. But it can work in a completely disconnected manner, because you have a container registry that's available locally as well. Now we're also working on bringing the core assets from AKS service, which is the managed service. We're working to bring that on top of Azure Stack as well. That will come sometime in next year. But when that comes, you'll have better ability to actually manage that cluster as well. So again, just look at it as a way that we continue to invest and make it better, right? Now, IT is one of those interesting things. When I grew up, people used to say in medicine, you have to keep studying, because you always have to learn something new. IT is actually much worse or much better, depending on whether you like studying. You have to keep knowing that something new will come, and IT is built with that. There's always some new innovation happening. And so we're going to continue to bring that innovation to Azure Stack as quickly as we can. Any other questions? Yes?
You said that with Azure Arc, you can manage the SQL on the AKS engine locally. Is the tenant as a CSP? Do you have to have in each customer tenant have a dedicated AKS cluster, or how is this going to work?
That's a really good question. So first of all, I want to be minor correction. You're not managing SQL, you're managing the data services platform, which can have SQL in the back end plus Postgres, one. So the question really is, do I need to have one instance of data services deployed per tenant, or is there a multi-tenanted data services platform? Right now, the data services platform is not multi-tenant aware. It has to be deployed per tenant, right? But Sean is in our team who works with the data services platform. We should chat more, and then the data services team is here, so we'll have to get feedback so they can understand the multi-tenant solution. But right now, it's single tenant. Any other questions? All right, you've been an amazing audience. I've rarely been able to walk through 54 slides in 48 minutes. Thank you so much. Really appreciate it.